Hi, I'm Rosenberg, the CEO and Chief Scientist of Unanimous AI, and today I'm going to be talking about conversational swarm intelligence, enabling real-time deliberative conversations at scale. And by at scale, I mean thoughtful conversations among large groups, 40 people, 400 people, 4,000 people, potentially even 4 million people. And this is really useful for a lot of applications, from enterprise collaboration to market research. But the area that I'm most interested in is deliberative civic engagement, engaging large groups of the population for deliberative democracy. And that's why I'm really pleased to be able to give the keynote here at the democracy session of Collective Intelligence 2024. And so with that said, a quick outline of what I'll be talking about. First, I'm going to talk about swarm intelligence, which is nature's method of amplifying the intelligence of large groups and enabling very smart, rapid decisions. It's not about aggregating data. It's about forming real-time deliberative systems, and that points us in a really interesting direction for human groups. I will also talk about the technology of artificial swarm intelligence, which is using AI and unique interfaces to enable distributed human groups to form similar real-time deliberative systems as biological swarms. I'll do a quick review of the first generation technology called swarm AI, which I actually presented here back in 2014 when we first developed it, and then I'll talk about the latest generation technology called conversational swarm intelligence, which we unveiled in 2023 and which continues to really, honestly, to amaze me what's possible. Then I'll talk about Thinkscape, which is a new software platform from Unanimous AI for conversational deliberation at scale with amplified intelligence. I'll talk about a few recent research studies we've done with researchers at Carnegie Mellon University that show the value of Thinkscape and conversational swarm intelligence to enable thoughtful deliberations and to amplify group intelligence. And then finally, I'll just talk about some of the use cases from enterprise collaboration to deliberative democracy and civic engagement. With that said, I want to start with a few words about collective intelligence. The one thing that unites all of us in the field of collective intelligence is that we believe that people are smart. And I say that because I speak at a lot of artificial intelligence conferences, and very few people in the artificial intelligence space start their work from that premise that people are smart. We do at Unanimous AI because we fundamentally believe that people, every individual, has a vast array of knowledge and wisdom and insight and experience and opinions and intuition and expertise in this remarkable human database. And what we've focused on for the last 10 years is really looking at how we can amplify the intelligence of groups based on what we've learned from nature and using the latest in AI technologies. And when I say amplify the intelligence of groups, what I really mean is enabling large groups to make smarter decisions, solve harder problems, and generate more accurate group insights. My personal driving philosophy in the field of collective intelligence is really to state up front that people are not just data points for mathematical aggregation. And I say that because so much in the world of collective intelligence has historically been done by polls and surveys or prediction markets where you're reducing people to data points and aggregating, and you see amplification of intelligence, but it's a moderate amplification of intelligence. What nature teaches us and what drives my philosophy is that people are not data points, people are data processors to be connected in real time. And when you do that and you allow them to deliberate in real time, you have a significantly greater amplification of intelligence and a much broader range of problems that you can solve. Which brings me to swarm intelligence, which has been what's driven my research and development over the last decade in this field. And it's nature's method of amplifying the intelligence of groups. And what nature does not do is nature does not take votes or polls or surveys. There's no survey monkey in nature. Nature also doesn't analyze big historical data sets, no big data in nature. Nature forms systems, real-time systems with feedback loops that enable groups to deliberate and converge on optimal solutions. And by deliberation, in the case of natural systems, really talking about a dynamic tug of war between perspectives, where there's large numbers of individuals who have different information, different perspectives. They're going to engage in a dynamic tug of war and ultimately find the solution of maximum conviction. And it's almost always the best solution. And I'll give some examples. Biologists call this swarm intelligence, and it's a primary reason why birds flock and fish school and bees swarm. They are smarter together than alone. And the big question that's driven my work over the last decade is, well, can human groups, large human groups, form a swarm intelligence and have similar benefits? And the answer is yes. Back in 2014, we developed and announced this technology of artificial swarm intelligence, also called swarm AI. And we developed this by studying how biological swarms work and developing algorithms and interfaces that allow humans to form similar groups. And so this is an artificial swarm, similar to what we developed in 2014 and have been studying many years since. And what you see here is about 100 people, and each one is controlling a little graphical magnet using a mouse or a touch screen or their phone. And a question might appear: what's the probability that interest rates will rise in the next 6 months? And all these people are collaboratively controlling that puck, but it's not a vote. It's a real-time system, a tug of war. Each person's controlling a puck to pull, controlling a magnet to pull on the puck. AI algorithms are watching all of their behaviors and determining the confidence and conviction of every person in real time. And so a swarm at a high level is a real-time system with participants acting and reacting and interacting, revealing the strength of their conviction to the underlying AI algorithms. And the really cool thing about artificial swarm intelligence is that, first, what the users see is really simple. It doesn't take any instruction. They just can control a magnet, question appears, and they just behave. They behave in real time. What the AI sees is a cloud of behavior, this deep behavioral data that it can use to assess confidence and conviction in real time. And the super cool thing about a swarm is that it's a real-time system with a feedback loop. And so what happens is, with this feedback loop, as a question appears, everybody starts to behave. The AI watches everybody's behavior and determines how the swarm should move. As soon as the swarm starts moving, everybody changes their behavior. They react. And as soon as they react, the AI updates its understanding of the confidence and conviction. And so the people influence the AI influences the people, and the system can find the trajectory to the answer that very often optimizes their collective confidence and conviction. And this works. How well does it work? We've done actually dozens of academic studies with major universities around the world. I'll just mention two that stand out to me. One, we did a collaborative project with MIT a few years back, where we had groups of financial traders do a 20-week experiment where every week they would predict the price of gold, the price of oil, and the S&P 500. They made those predictions alone. They made those predictions by taking basically just a statistical aggregation, traditional collective intelligence, and then they made those predictions as a real-time swarm, predicting the direction of each of these different assets. And what we found, and this study's on our website, it's published, it was that when working together as a swarm, we amplified their collective intelligence by 26%. We did another study that with Stanford University Medical School, funded by NSF, where we had groups of doctors, radiologists, and these were small groups, just 5 or 6 doctors. The financial trader study was 15 to 20 traders. Here was just 5 or 6 doctors. Chest X-ray would pop up on their screen, and they were asked to predict the probability that the patient has pneumonia. And they made these predictions alone, predicted a probability. We did the wisdom of crowd, taking the statistical average of those predictions, or we had them work together as a dynamic swarm to converge on predictions. And what we found was that when they worked together as a swarm intelligence, we reduced their diagnostic errors by 33%. And that was published in the journal Nature Digital Medicine, and it's on our website. And there's many, many other studies that were done. But the key thing is that artificial swarm intelligence works. It enables groups to reach improved decisions quickly and decisively as a deliberative system, and it amplifies intelligence as compared to statistical aggregation. We almost always see it be statistical aggregation, or in the worst case, tie. But it's not the optimal way for groups to deliberate, for human groups to deliberate, because one, we lose information. We don't get the reasons why. We just get the answer, which is also true of statistical aggregation. And so the big research question that's driven my work recently is, well, can we harness the power of swarm intelligence to get the reason why, but also to address open-ended problems? These graphical swarms allow you to do numerical forecast, allow you to answer a multiple choice question. But really, to solve hard problems, complex problems, you want to be able to do open-ended problems where groups need to brainstorm and deliberate and debate and converge on optimal solutions. Can we do that using swarm intelligence? And can we capture the underlying reasons why? And so with that said, the place that we focused on for a while is, well, how can we bring the power of swarm intelligence to conversational deliberation? Why? Conversational deliberation is really the most important collaboration methods for evaluating problems, generating ideas, surfacing insights, and finding solutions among human groups that want to harness their combined knowledge and wisdom and insight and intuition. It's a human superpower, but there's a limitation, which is that conversations are really only viable for use in small groups. It turns out that the ideal size for a human deliberation, based on historic research, is about 4 to 7 people. 4 to 7 people can have a thoughtful deliberation. They get a good amount of airtime per person, a small amount of wait time to respond to other people. But as you increase a group size, airtime goes down, wait time goes up, and it starts to devolve. Above 10 to 12 people, it really just becomes a series of monologues. And above 20 people, it's really not a conversation at all. It's maybe a one-to-many presentation. And so this has been a fundamental problem. We humans now function in very large groups, and yet we can't access our core ability, conversational deliberation in real time. What do you do if you have a large group of 25 people, 50 people, 500 people, 5,000 people? How can you enable thoughtful and productive real-time conversation? Well, it turns out that we can solve this with a little help from Mother Nature. And so let's talk a little bit about fish schools, which is really the inspiration for how we can solve this problem. Fish schools are pretty remarkable. There's thousands of members, and they make decisions so well and so fast together that biologists often refer to them as a superorganism. And they communicate with each other using a special organ called a lateral line. Lateral line is on the side of their body, and it can detect pressure changes and vibrations in the water around them, so they can understand the intentions of the other fish in their neighbors, their near neighbors. They can understand what direction and speed their neighbors want the school to go by detecting these signals in the water. And so it becomes this deliberation, a small local deliberation among a small local group. The magic happens because all these little local groups overlap, and so information can propagate through the full school. And this yields smart, rapid decisions in real time. And so let's look at an example. And so how do fish schools make smart decisions? Let's give this school a decision to make. Here's a fish school. It's like think of it as an organization, a large organization. It has a complex problem, in this case, 3 predators that are approaching from different directions. What's really interesting is that in this organization, all the individuals have very limited information, and no individuals have enough information to make an optimal decision. In fact, most of the fish in this school probably have no idea that there's a predator approaching. What we do know is that in 3 portions of the fish school, fish are aware. The fish in the upper left are aware of a predator, likely want the school to move down and to the right. The fish in the lower left are aware of a predator. They have their deliberation and likely decide that the school should move up and to the left. And the fish in the upper right have their deliberation and likely push and pull and decide that the school should move down and to the left. So those are 3 local deliberations. That doesn't become a collective intelligence. It doesn't solve the problem. The problem gets solved because these groups of fish overlap, and the information can propagate through the school, and very quickly, this school can make a rapid and effective, smart decision that addresses the complexities of their world. And I will say this is a really good analogy for large human groups. Large human groups need to make decisions. Large organization, the individuals all have limited information. They all have different expertise, different knowledge. No individual likely has enough information to solve the problem in a complex problem, and they need to be able to deliberate in real time if they want to solve this problem efficiently, and in the case of fish school, potentially optimally. And so how do we do this in human groups? Well, let's imagine we have a group of 250 people. Real-time conversational deliberation is impossible for groups this large. There's no technology out there that allows this as a real-time deliberation. Mother Nature would say, well, what we should do is take this group and divide it into small groups that are optimized in size for thoughtful real-time deliberation. And so we could take 250 people, we could break them up into 50 groups of 5. That works. I could have this large group come into a chat environment and break them up into 50 groups of 5. I could have large groups come into a massive teleconference, Zoom, and break them up into 50 groups of 5. That's interesting, but that doesn't create a collective intelligence. That doesn't create a single unified conversation. It doesn't optimize the intelligence of the group. Well, Mother Nature would say, well, the thing you need to do is have these groups overlap, just like in a fish school. Okay, we could do that. We've spent a lot of time experimenting with that at Unanimous AI in lots of different contexts. It turns out that this fails when in a conversational context. It fails because humans are not fish, and we didn't evolve with the same capability of fish to be in these overlapping conversations. In fact, we evolved the opposite way. There's something called the cocktail party problem, where if you're at a cocktail party, you could be talking to your small group, but if you start paying attention to the small group next to you because you hear something interesting, you start to lose the ability to focus on either group if you're trying to pay attention to both. And so, in fact, we humans evolved the opposite capability. We're really good at blocking out all the other groups if we're at a cocktail party and just focusing on the conversation that we want to. And so this does not work, and this has seemed like a possible problem to solve. And yet we found a really amazing way to solve it that works, which is that we created an artificial agent that we can then replicate and put into all of these different groups. We call this a conversational surrogate agent. It gets put into all of these little local groups, and this conversational surrogate agent has some important tasks. It goes into this local deliberation. It observes the local deliberation. It extracts insights from this local deliberation in real time. It passes insights to other groups in real time in intelligent ways based on the strength of sentiments. And then it receives insights passed to it from other groups. And when it does, it expresses those insights in its local group conversationally. And so now you have, let's say, 50 local groups. Each one now has, let's say, 5 people and 1 conversational surrogate agent. That the conversational surrogate's not making up information. It's just participating in the conversation based on the insights it's receiving from other groups. So it's representing insights from other groups. And so all the participants are having just a thoughtful local conversation, but they're all connected together in real time. Information is propagating through the full network, just like a fish school, but actually more efficiently because we can send information in optimal ways. And this allows a large group, 250 people, 500 people, potentially 1 million people, to hold a single conversation and harness their collective intelligence in real time. And we call this conversational swarm intelligence. And we've built this and we've tested this. And this works. It allows for real-time conversational deliberations in real time. We've enabled this and built this for first for text-based conversations, where we can have a large group automatically get broken up into these different text groups with a conversational agent in each group and information passing between all the groups, and that works. We've also developed an architecture for video deliberations, where the same thing can happen in a video environment, but now there's a photorealistic avatar in each group that's representing the views of other groups and weaving the whole conversation together. We call this conversational swarm intelligence, and we've built an online cloud-based platform called Thinkscape that's currently text-based or voice-to-text, not video avatar-based. We built Thinkscape, and we've been testing Thinkscape, and I will talk about it. But before I show the platform, does it make groups smarter? That's obviously one of the big questions. We've run lots of studies in collaboration with different universities. I'm just going to mention one or two, actually. We did an estimation study where we've asked groups of people to estimate the number of gumballs in a jar. We did this because it's a classic collective intelligence study that people do all the time by just taking surveys. And so we had 250 people. They were shown a photograph of gumballs in a jar. We asked them to estimate the number. We asked them to do this in different contexts. First we looked at what's the average individual's error when estimating gumballs in a jar when it shows up on the screen. We asked ChatGPT-4, pure AI, to do this, just to see how do we compare to artificial intelligence. This was last year, so this is not the latest GPT-4. We did this as wisdom of crowd. So we took groups of 250 people, and we took the statistical aggregation of their estimates because research suggests that would amplify their accuracy. And then we did this as a conversational swarm, where they deliberated conversationally and converged on an answer. And what did we see? We saw that the average individual had a 55% error. That's a big error, but this is hard. We then asked ChatGPT-4, 42% error, which really amazed me. It scared me or amazed me. Even last year, ChatGPT-4 was able to estimate better than the average human. That is amazing. But wisdom of crowd, taking the statistical average of 250 people, took the crown back for humans. We got it down to a 25% error. And so wisdom of crowd works. It cut the error in half from the average individual. And then we had them deliberate as conversational swarm as an alternate method, and the error was dropped to 12% error. Cut the error in half yet again when they could deliberate as a conversational swarm. And so there's a published study. It's on our website. You can check it out, but you can see the estimation error comes down. The second study that I'll mention is we wanted to look at a more complicated type of question, and we had groups take an IQ test in groups of 35 people. This is a graphical IQ test called Raven's Matrices. Question pops up, and we had different examples. We had people take the test as individuals, just giving us their individual answers. We did a wisdom of crowd, where we took the most popular answer for each as the answer to see how just statistical aggregation would work, and we did it as conversational swarms. We did not ask ChatGPT-4 because presumably ChatGPT-4 is trained on data and likely had the answer key in its training set, so that wouldn't have been fair. So the average individual scored 100 IQ with 50th percentile, which is what you'd expect. That's how IQ tests are designed. Wisdom of crowd, you take the most popular answer. This works. You get 115 IQ up to the 81st percentile. But when they deliberated as a conversational swarm, in real time, having the same amount of time per question as allowed in the other cases, they jumped up to 128 IQ, up to the 97th percentile. And even more remarkable is that it consistently outperformed every member of the group. In fact, in each of these groups of 35, we never saw an individual who outperformed the conversational swarm in that group. And this is a published study, also on our website, that you can check out. And so that shows that this works, and we've seen other really interesting studies that show that not only do groups get smarter, but they actually contribute 50% more conversation per person than if they were in a single large group communicating. We also see a much smaller difference between loud mouths and silent, more silent people when they're in these deliberative groups than in a single large group. So there's all kinds of benefits, and those papers are on our website. But I'll talk about now just the Thinkscape platform itself. So this is Thinkscape. Groups of up to 500 people can log in from anywhere in the world. When they log in, they enter an environment that looks like this. We can see who the participants are. In this case, there's 112 people and a few moderators in this group. They can come in with named accounts, or they could come in anonymously with randomly assigned names. Lots of different reasons to do either. There's an area where the groups can chat in real time. There's an area where media can be shown. It can be larger than that. They can show images, spreadsheets, videos as part of the deliberation. And then there's this deliberation visualizer that allows people to have the mental model of how information is passing around the system. Because what's happened here in this deliberation visualizer is you have 112 people, and they've been broken up into 23 different small little groups of 5. They've automatically were split up into these groups, and they're going to have conversations locally in their groups. Again, this is text-based, but it also has voice to text, so they can just speak into the system. And this is the moderator view. And so from the moderator view, when the conversation starts, I should say, there's a moderator who can ask a question. And so in this case, the question was, this is actually was done for a major market research firm. It was, which of these snack brands is most associated with novelty and why? And so here you have 112 people who are going to deliberate and debate about various snack brands. And so you can think of this as a focus group, but not of 8 people, of 112 people, broken up basically into 23 focus groups in real time, all woven together by AI into a single deliberation. And when that deliberation starts, and this is sped up a little bit, but 112 people, lots of conversation happening. Still, it's tracking the sentiment towards different snack brands in real time. But this is really not the view that you'd want to have to watch this session. But the really cool thing is you can click on any one of these think tanks, just jump in and see, well, what's happening in this little group of 5 people, and here you can see it's a thoughtful conversation. The AI surrogate is bringing conversation into it from other groups in smart ways. They're having their deliberation. It's weaving the whole conversation together. Even this is not the best way to watch this large-scale conversation in real time. And so because we're doing all the AI in real time, you can actually click and go to this insights view. And so here, and again, this is sped up a little bit, but here you can watch in real time as sentiments emerge for each of the different snack brands. You can scroll down. It would tell you the reasons for why each of the different snack brands is being supported, the reasons that they're not being supported. It's extracting these key verbatims in real time so that an observer can actually see just key sentences from each of the different 23 groups. And again, because this is happening in real time, a super cool thing is that at the end of this deliberation, which I think was only 6 or 7 minutes for them to deliberate this question, and then they went on to a whole series of questions about these different snack brands. At the end of this question, we already have a computation of what is the core collective sentiment of this group of 112 people, and we can express it conversationally, which we do either just through text or through audio or through a real-time avatar like this.
I am Una, a collective intelligence created in Thinkscape by connecting 112 consumers in AI-powered deliberation. Our collective perspective is that Cheetos is the brand most associated with novelty. That's because it offers a variety of bold flavors, has unique advertising, and offers experimental options that represent adventure. We also find Cheetos to be a reliable pick-me-up and a nostalgic brand. For more details, please see the full written report generated by Thinkscape.
So as you can see, the moderator gets a quick assessment of exactly what happened in this complicated, basically 23 focus groups all woven together. They can use that real-time reporting to help guide the next question that gets asked to the group. But as Una said, the system, Thinkscape, also automatically puts out a full written report, and it generates this within an hour, and it reveals a full statistical analysis of the qualitative sentiments that are captured, because we're capturing qualitative sentiments at scale. This was 116 people. It could have been 500 people, but in either case, within an hour, you get a report that pops out that has a full statistical analysis of the sentiments for each of the different snack brands, the reasons and support, graphs of sentiment, word clouds, assessment of positive and negative statements, and a clear verbal description of what this large group thought about each of the different brands. Obviously, snack brands is interesting for market research, and we see lots of interest for market research, but the exact same thing could be done for enterprise collaboration. A large group wanting to prioritize, what are their business priorities for the next 6 months, and have a large deliberation, brainstorm together, prioritize, and then get a full analysis of exactly what is this group of 200 or 500 employees, what's their real collective sentiment, collective will about priorities in real time. And so that is the technology of conversational swarm intelligence. Again, it takes networked human groups who have knowledge and wisdom and insight and experience, and it connects them together with conversational swarm intelligence, which is, again, the biological principle of swarm intelligence combined with large language models to enable large groups to have conversational deliberations at scale, thoughtful deliberations at scale, brainstorm at scale, prioritize at scale, forecast at scale, and it yields more accurate decisions, assessments, insights, forecasts, prioritizations, and it gives deep analysis of the underlying reasons why. I'm Louis Rosenberg, company is Unanimous AI, and if you want to learn more about what we do, visit our website, and our product Thinkscape is available for all kinds of applications, but we're really interested in parties that want to use it for deliberative civic engagement, for having large groups engaging in deliberative democracy and really exchanging ideas and converging on good solutions to hard problems.